Well, hey there, everybody. So today I'm gonna draw a Sharp V screw for us here. Um, if you guys aren't familiar, this is the Technical Drawing with Engineering Graphics book, and it's gonna be what I reference for all of the drawing on it. So first things first, you're gonna have a thread profile, and over here on page 596, you got kind of a picture of each one. So I'll be referencing this on every video I make, but it's pretty basic formula. Basically, all you need to draw is the pitch and the 60 degrees. The D is not even required because obviously you can produce it without it. So then I'm gonna go ahead and jump down. But basically, the principle is, you're gonna have a pitch, and it's determined by an inch divided by the amount of teeth, which is given in the thread note. And I may have scrolled past that already. Let me take a look here. Apparently not. Okay, so if you look here on page 604, and it's probably best to specify this is the 15th edition book, so it's the newest one. But so if you look, you've got threads per inch listed here in the diameter, and that's pretty much all you're going to need to draw it most of the time, but there is, other modifiers that matter. The class of fit, of course, blah, blah, blah. I have a video on that too. But, for our intent, what we're going to do today, we'll just need like the major diameter, threads per inch, and if it's left hand or right hand. And then, there's a metric one broken down here as well. Now, to go back up, it's like this is pretty much just the gist of what it's going to look like. I don't know why in the book they wanted to flip it the other way and, kind of make it a little more stressing. Like if they would have had the 0.5 over here and the, the P over here, it would have been great. But I think they were trying to, since you read left to right, let you read what the actual lines look like first. But to me, it just confuses it up. But the principle here is on a standard screw, like a single thread or even a 3-star thread, a triple, you're going to have a profile drawn, and then that same profile will be copied and pasted straight down. So then when you look at like a 2, or I assume a 4 if there was a 4, it's going to be the opposite. So you're going to have a profile drawn up here, and then you're going to mirror it down here. So it really matters a lot about placement of these profiles in addition to drawing them. And then after that, you're pretty much just connecting the dots. So let's go ahead and open up an Imperial template. And I'm going to kind of just ballpark some values here. But, the general idea is going to be the same regardless. So let's see. First of all, I'm just going to draw on a pretty good spot in the page. And let's make it have like a shaft of 1 before we actually get to the part itself. And I guess like 2 inches by 1. And, so I don't know how some people draw like the little breaks in a screw. But what I like to do is take that value of whatever it was. Oh, you know what? I'm on the wrong arc. Okay, so I'm looking for start and radius. Yeah. So like what I like to do is take the radius value of that thing and use it. Huh. Come on, you. That way it has like a perfect transition. And then just mirror this one down here. And you can delete this line out. And then, later we'll hatch this portion. But basically, yeah, like that's just a smooth break because you've got, the transition is not sharp. Now, there's probably a better way to do that, but this is the best I've found. And that's just, a guess, really, at what's the standard. Okay, so let's do like a 4-inch length. And what did I make this to? We may as well just make it straight across. Doesn't have to be, but for this one we'll make it this way. So I'm going to go ahead and trim and delete my center line that I made. So I need to determine the thread pitch, by the way. So let's go ahead and do like a generic note here. So like what I'm gonna do is, let's see. I don't want it to be too small. Okay, how about we do 4 threads per inch? Let's see how that looks. Or no, let's do 6. 6 TPI threads per inch. Right hand, and yeah, I mean that's pretty much it. You already know the diameter technically, but I'll put it down here. 2% C. Okay, so that's my own note. Obviously, this is not proper nomenclature, but it lets you see, you know, what's going on if you're thinking about it. So anyway, I'm going to do a calculation here, first of all, and it will be 1 divided by 6. So we'll do a couple decimal places. So we'll do 1.6667. How about that? 1.6667. Okay, and then I'm just going to, oh, bad maths, 0.16667. Okay. And you know, some people offset the lines outside of the screw, so it's easier to delete, but I kind of like it being here. To me, it's a little easier not to get goofed up. That one seemed to line up perfectly, so. Lots of these guys. I really don't need them. I mean, honestly, I'm probably just going to delete them all, but it's fine. So then, what you're going to want to do, you know, really I don't need that, is to draw the line connecting the 2 ends of that pitch. Make sure that you've got your snap set to 30s. And then once you get that snap, go ahead and draw. And so like that's going to be our minor diameter right there. So then, you know what? I think I've already blew it on my end. Let's see. Yeah, so, okay, I'm good. I was thinking that maybe it started at the middle, but it starts here. So anyway, I'm going to trim. And then all I need to do is copy it. Might as well get a bigger selection here. And let's do the same thing one more time. You know what? We'll just do it the quick way. Hold Shift to deselect. Okay, so now if we look back, it slopes up and it slopes up. So this is what I was talking about earlier. All you need to do is just copy everything and move it straight down to the bottom. It actually needs to be longer still. I didn't realize that. Okay, no biggie. So we'll just copy this whole batch. It's kind of a long screw. It's fine. Let's shorten it by an inch. It seems like 3 is plenty. Can't tell if it's the same ones or not, but we'll find out. Oh no, I blew it. Okay, no biggie. We don't need that many anyways. Alright, so I'm going to delete this guy and that guy. And I'm not even going to bother to trim that right now because we're going to end up having a chamfer on this one. So, so if it's going right-handed, you know, it's going to basically travel this way, you know, and if it's left, it would travel this way. And the reason being, so like say, you know, I had a bunch of these lines like this. you can kind of tell if you're thinking about it. If this is rotating clockwise, it's going to be traveling along this path, getting further into it. Basically, it's literally traversing and digging deeper into it. So of course, this would be progressing forwards, which is the concept. So yeah, it's going to be positioned just like this. So then it's pretty straightforward process. You're basically going to connect. Okay, so let's look over here. Basically, like this top point, you're going to connect it to the top point on the bottom. But if you're looking, the idea is basically if you were to draw a line straight down, you're going to be touching the point on this end, but then it'll be at the bottom here, and you just need to actually connect it here. So like technically you have the end here, but you can't see all of that. So like if you were to move to the next one, here's this, straight down is here, so you move forward a half of a pitch. So in this one, you know, I could draw a straight line down. I can see that's where it would be. So this is where this one would connect. And then the same concept applies with the roots as well. You're going to connect those in the same process. So, you know, usually what I like to do, this one's pretty easy, so it's not really a scary one, and it's pretty easy to tell if it's right or not. But the best way to fact check and see if you're right is to dimension from that straight line, basically. So we've got 0.0833, which is half of that 0.1667, whatever it was from earlier. So then from that same line, I can go to the bottom one, and you see it's that was a bad click, guys. But you can see it's double that. So we have half of the pitch and the actual pitch. So basically all you gotta do to fact check these is literally just measure from the start to the next one and see if it, you know, lines up. Your lead should always match this formula, and your start always should match that. And obviously your slope is the same way. All it's showing here with the dotted line is that, you know, this is symmetrical. It's harder to see on that one, but this one you can kind of tell. So like you have this line, and if you were to draw a line straight down, this line right here, I'm pointing very poorly with this line, it's mirrored to this one basically. So this is just on the back end. It's a hidden line for a reason. Basically, you could measure this on either end of the spectrum. But we've already measured it. It works out. So there's no reason for me to like go and try to draw all of this again. I'm going to do the same thing. I'm just going to copy it across as we go. Oh, I think I pasted it a little too often there. Okay, so now I need to copy for this little portion right here. So I'm just gonna copy. And this one's great because, you know, you don't have to do any really trimming outside of the profile. Now, one thing, it's not mandatory, so you really just have to see what the thread calls for. But sometimes you may have a chamfer on the end of it. So like this, you know, it's traditional looking, pretty basic. If you do have a chamfer though, draw a straight horizontal line from that minor diameter on both ends. And then at the end of the part where it meets that line, draw a 45-degree line and just trim the excess. Pretty straightforward concept. Works pretty great in practice though. So now I'll just trim, delete this guy. And there you have it. You've got your chamfer. The only thing left to do is just to hatch it. Yep. So, you know, if you go and you look, we have 1, 2, 3, 4, 5, 6. You know what? I think I measured that wrong. Yeah, okay. So you're supposed to include 1, 2, 3, 4, 5, 6. What? Oh, because it's to the midpoint. Yeah, so you've got half here. So you got 1, 2, 3, 4, 5, and then half plus half, so that's 6. But yeah, so there's your threads per inch. Obviously the diameter is the same as this, and you got your chamfer. So it's pretty straightforward. The next ones will be worse, but obviously, you know, this is a right-handed thread. You could practically mirror this to get the left hand, but the only difference would be it would be going the opposite direction. So if that were the case, you know, you would just be doing from straight down this direction. You know, that's the only difference. So pretty straightforward. I don't expect you guys to have much issues with these.